Hello, this has been McGahee with McGahee Mathematics. Today's video we're going to learn factoring trinomials, second part of the form ax squared plus bx plus c, and we'll note that a is not equal to 1 because in the last video we had x squared plus bx plus c, and we know there was a 1 in front, a coefficient for x squared, and in this case we're going to look at values where a is not equal to 1 and see how to factor those types of trinomials. So let's take a look at one type example, and it starts off with 2x squared plus 6x plus 4. 2x squared plus 6x plus 4. So in this example, we can see that each of these numbers, coefficients 2, 6, and 4, they're all even numbers, so they all share common factor. So what we're going to do is use what's called the greatest common factor out of all of these numbers, 2, 6, and 4. So we know 2 is 2 times 1. 6 is 3 times 2. 4, 2 times 2. So you can see that the greatest common factor out of all three numbers is 2. So we'll have a 2 factor outside. And then what goes on the inside is what's left over. So my x squared term is left over for 2x squared, so I'll put x squared here. And then plus, then I think about what 2 times what is 6x. So I know that 2 times 3 is 6, so I have 3. And then I just attach x next to it. So I know 2 times 3x is 6x. And then plus 2 times what is 4? Well, that's 2, right? 2 times 2 is 4. So I have 2 times the quantity x squared plus 3x plus 2. Now I ask myself, can this be factored even more? Is it factored completely? Well, if we look at x squared plus 3x plus 2, we can see that yes, it can be factored, because I know factors of 2 that add up to 3. So I know 2 times 1 is 2, and 2 plus 1 is 3. So I can factor this as 2 times, remember for x squared we have x and x, and then our factors of 2 that add up to 3 are 2 and 1. So we'll have x plus, we'll just do it in order, x plus 1, x plus 2. So this will be our final answer for this problem. 2 times x plus 1 times x plus 2. So this was called, using the greatest common factor. So we'll write that as GCF. And it's going to be very common when you're doing factoring problems or trinomials or with any other kind of factoring types of polynomials you come across. So always look for a GCF in all three terms possible. So the next type that we're going to look at is one that doesn't have a GCF but requires a little bit different treatment to help us solve it. So in this problem we have 5x squared plus 8x minus 21. So we look at, the coefficients 5, 8, negative 21. So 5 is a prime number. It's just 1 and 5. 8's even. It's like 2 and 4. Or 8 and 1. And negative 21 is like 3 and 7 or 1 and 21. So we see that none of these three numbers share a common factor. So the GCF possibility is out of question. So we need to use another technique to factor this trinomial. And this will be called what we call the grouping method. So I'll just abbreviate GRP method. So this is called the grouping method. And what the grouping method tells us to do is to multiply 5 times negative 21, multiply the A term times the C term. So let's see what that is. 21 times 5 is, what's that? 1 times 5 is 5. 2 times 5 is 10. So 105, but with the negative sign, right? Because positive times negative is negative. And we have to find factors of negative 105 that add up to the middle number 8. So I know if I were to make a factor tree that this number ends in 5, so I know it's divisible by 5. So 105, see 5, so 5 times what? It's 105. So just doing my division, it's 2 times 10, bring down the 5, 5's once, so it's 21, right? And then I know 7 times 3 is 21. So I'm going to use a combination, pick a pair out of these three. Right? 5, 7, and 3. So the numbers on the end of the factoring tree, use 2 out of those 3, multiply them together, get one factor, and then the other one remaining is the other factor. So what I can do is, let's say if I pick 5 times 7, that's 35. That's my one factor. And I know 35 times 3 is 105, because that's our number right there. But as any combination, whether these are positive or negative for 35 and 3, will they add up to 8? The answer is no. So we need to try a different pairing. Let's say if we do 5 and 3, it's 15, so that's one factor. And then 7's our other one. So 15 times 7, 105. So one of these has to be positive, the other has to be negative. So I know that 15, and then if I subtract 7, that gives me 8, right? So that's what we're looking for. So my factor would be, I got my 15 and negative 7. So continuing on, we found that 8x, right? That's equal to, we have 15 minus 7 is 8, so that'd be 15x minus 7x. So what I'm going to do is rewrite the middle term, that 8x term. I'm going to rewrite that as 15x minus 7x. So it'll be 5x squared minus 15x, or sorry, that's plus 15x minus 7x minus 21. So you see what I did? I just replaced this 8x term with 15x minus 7x, because 15x minus 7x is 8x. And now I use technique called factor by grouping. So the factor by grouping goes like this. We take one group here, 5x squared plus 15x, we'll factor this group, and then our other group, second group, is negative 7x minus 21, and we factor that group, and then somehow we'll be able to factor the whole thing. So doing this to the side over here, let's do 5x squared plus 15x. So we look for greatest common factor. In GCF, we have 5 and 15, so we know a 5 can come outside. We also have powers of x for each term. We have x squared and x, so we know that the greatest common factor out of these two would be just x, because both of them have common power x. So 5x and then times 5x times what is 5x squared? Well, all we need is one more power of x, so we just have x, because 5x times x is 5x squared. And then plus 5x times what is 15x, so we already have x here, so 5 times 3 is 15, and then we know 5x times 3 is 15x, so that works. So that takes care of the first group, and we'll just write that down here. Now for the second group, we have negative 7x minus 21. So we look at the coefficients, negative 7 and negative 21. So the greatest common factor out of those, and notice that minus 21 doesn't have an x, so the only number that will come out, or the only greatest common factor we have, is just a number. There won't be an x next to it. So the greatest common factor would be what? Negative 7, right? And so the only thing that's missing here for negative 7x is the x. And then negative 7 times what is negative 21? Well, negative 7 times 3 is negative 21, so it'll be plus 3. So that would be my other part, is minus 7 times x plus 3. Now for the last part, we get to the factor by grouping. We grouped each factor, and we notice that both groups have a common factor of x plus 3. So we'll factor this outside, x plus 3. And how do we get our other factor? It's just through the distributive property of combining the 5x minus 7. So the sum of those two terms, 5x minus 7, or difference, if you want to think of subtraction, so 5x minus 7 would be our other factor. And there's our answer. X plus 3 times 5x minus 7. Okay, so those are a couple examples that I wanted to show you on factoring trinomials. This has been McGahee with McGahee Mathematics. Thank you for watching this video on trinomials. We will take a look at how to factor the difference of squares, and we'll even take a look at later on the sum and difference of cubes. So stay tuned.